Hello, this is Bilkent University Physics 101 experiment. The topic is observing the relative change in velocity and acceleration of moving objects using ultrasonic waves. I am Yavuz Alp Sencer Öztürk from Computer Science Department. The purpose of this experiment to observe how the velocity and acceleration are related to the observer by observing the displacement and time change with the help of the ultrasonic sensor. In this experiment, I will start with measuring the speed of sound, and then using this information and equations of motions, I will calculate the distance, velocity and acceleration without and with relative acceleration of objects. First, start with measuring the speed of sound using ultrasonic sensor. Ultrasonic sensors work by emitting sound waves at a frequency too high for humans to hear. And then they wait for the sound reflected back and calculating the time difference between two waves. Using a known distance and the time difference between two sound waves, actually we can calculate the speed of sound using the equation on the screen. And in the table, you can see the time in microsecond and distance in centimeter, which is calculated in the experiment. And the time distance graph is a linear graph as it is expected, and the errors are measured as it can be seen in the trend line of the graph. And this is the equation of average velocity, and using the time traveled and the distance, I calculated the speed of sound as 341 meters per second, almost. Using the equation of distance, which can be seen in the screen, x equals x0 plus v times t. As we know, the v, speed of sound, and the t, the time traveled, we can calculate the distance between sensor and the object. However, the distance traveled by the sound waves is not equal to the distance we want to find, because the sound waves travels the same distance two times as reaching the object and reaching the sensor from the object. So we should divide it by 2. Using the equation of motion, I programmed the car to show us the distance, and in the video you can see it is really precisely calculating the distance between the sensor and the object. To calculate velocity and acceleration, we will need the distance traveled and the time between two distances. To measure the velocity and acceleration, I programmed the car to show us the distance between object and the car on the LCD screen, so that I can capture them with a camera and then tabulate the data into a table and then produce the graphs. However, as it can be seen in the video, the data cannot be read from the camera, but I have found another way to reach the data, and in the table you can see the results. Using the average velocity equation and the acceleration equation, I calculated the velocity and acceleration of the car between the given time intervals. And this is also the same calculations done on when the object is moving instead of car, without acceleration. And when we compare two tables, as you can see, the difference is so small, as we can see it better on the graphs. This is the distance time graph and the trend line with which is corrected errors. This is the velocity time graph. And this is the acceleration graph, which is almost 0. And in the part 4, I will calculate the relative displacement, velocity and acceleration of objects and the car, but in this time I will move the car and object with acceleration. This is a video from the experiment, which I record the data I will use to tabulate the data. Using the same equations in the part 3, I calculated the velocity and acceleration of the car and object by using the time and distance. This is the same table for when object is moving. And when we compare two tables, you can see the difference is so small, and we can see this on the graphs easily. This is the distance time graph. This is the velocity time graph. And this is the acceleration graph. Different from the part 3, there is the acceleration in this part. In conclusion, when we compare the distance, velocity and acceleration graphs of relative motion, as there is almost no difference, we experimentally proved that the distance, velocity and acceleration are relative quantities. But I want to mention the problems caused the errors in the experiment. First, due to friction, I couldn't stabilize the speed of car as I wanted. So, the first values of the graphs are little different than the expected values. Second, due to problems caused by the tools I have used, such as motors and microprocessor, the results are affected. And finally, the precision of ultrasonic sensor is not perfect, which sometimes produces wrong data. However, to solve these issues, I tried to do same experiment many times and take the average values to minimize the errors. And at the end, if you want to repeat this experiment, you can find the materials I used and the codes I wrote in the description. Thank you for watching.